Yes. Assalamu alaikum. Bismillahir Rahmanir Rahim. Actually, previously we have covered until until the trigonometric form. Today I am going to discuss the complex form or the exponential form of Fourier series. This is, as we know, that the exponential form of the Fourier series is f of t c naught. C naught is the average value, and Cn, that is the complex function, and it is given by En minus Cp divided by 2, and the magnitude of this one is An square plus Bn square divided by 2, and theta n is given by, if An is greater than 0, then it's a simply En over N. If it is less than 1, then the formula is given like that. This is just the, maybe you didn't see these formulas before, or you have seen it in some other form. But if you carefully examine your previous knowledge and this knowledge, these are the same. An or Bn, you can see that it's 2Cn cos theta n, and Pn is 2Cn sin theta n. Writing cos n omega naught t plus theta n in exponential form using Euler identity. Okay, you already know the Euler identity, and you can write down in that form very easily. Go back, this is your main expression. It is from n1 to nn, and Cn is given by like that, and now you have to define An from the Cn and Bn from Cn. Okay, this is your function, which is given by C naught plus n minus infinity to infinity. Okay, and Cn e j n omega naught t, and this is just, if you have to remove, this doesn't exist at n is equal to 0, because why doesn't exist, because C naught is over here, and if you write down the combined form, it will be given like that, and your complex coefficient is defined by the similar function t1 over t naught plus 1 f of t. You have already seen this form, I'm sure you have followed this, and your Cn is equal to complex continuum C minus n, uh, which clearly describes the coefficient for the negative n or the complex conjugate of the coefficient for positive n. Okay, you can easily determine the coefficient. If you find the 1, then take the complex conjugate, it will be for the respective negative side. Okay, determine the complex Fourier series for this function. The average value of f of t is 0, you already know that. C naught is 0, it's a even function. Even function, it is 0. Why it is 0? If you look at the time, if you take from minus t by 2 go to t by 2, whatever is positive, similar is the negative. If you start from here, like from this point, this is the starting point of your period and this is the ending point of your period. This one is positive area under the curve, this is negative area. These are cancelled out and average value is 0. That's pretty clear. And for the nth values, the coefficient, it is given like that. Just we are using the formula, we select t naught minus t by 2. Just from here to here, this is the convention, and define j n omega naught is equal to m, because it's just the, it's causing the confusion. We just make it a one variable. T is the only important term because it is integrated over T. What next? Thus evaluate it, and you can see the results. Cn is equal to minus plus and minus. Actually, what it is exactly, if you take the integral and you come up with only, okay, you need to be smart for that. For this minus t by 2 to t by 2, look at the function t by 2 to this is t by 4, there is different value. From t by 4 to 0 different value, and 0 to t by 4 different value. Okay, although these are the same, but you are for integrating you need to minus t by 2 to minus t by 4, minus t by 4 to t by 4, and t by 4 to t by 2. Okay, this is taken from here, minus t by 4 to minus t by 2 to minus t by 4, and next one is from here to here, yeah, this one, and then this one. Okay, there are three different intervals, and when you are going to evaluate these two, this is pretty simple mathematics. Just simplify it and put the values of this m to avoid the confusion. 2 ejn pi by 2 minus 2, just put up the values and simplify it, and at the end when you just using the Euler identity, you can sum up the form like that. If n is even, then these terms are 0. For n is odd, these terms are can be summed up like that. For odd number, you can just simplify these like this. And more generally, if you define x is equal to n pi by 2, this is x, then you can also simplify the first option, sin x over x. It's a very simple exercise, but maybe it looks complex to you. But if you carefully evaluate, the most important thing is that interval selections and integrating it very carefully. We left with this one. Since f of t is an even function, all Cn are real and equal to 0 for n is even. You already seen that. If you put the value n is equal to 1, you will see the value n is equal to 2, you will see it is equal to 0, n is equal to 3. There always exist some values. Okay, and also you know that it's a complex conjugate. Since there is no complex part involved in this case, so these both are equals. However, for the even value, you already know that is even is 0. Okay, and the complex Fourier series is given by like this. Just you need to write down these values into that formula. Let's go back to that formula. C1, C2, C3, you have already have it. This is your formula for the Cn, and this is your function. C0, this is your function actually. C1 and against that C2, against that minus C1. That is the point which I am trying to make it clear to you. This is minus 3, minus 1, even is 0, 1 and 3, and then add them up, make it simple, and this is using the Euler identity. You can Yes, okay, look at that. They make life pretty much easier for, and look at that, they also made it more simpler by giving some precise question. And you already know that for real f of t, real functions, these complex conjugates are in this complex conjugate of Cn is equal to the Cn itself. Oh, there is another example. This is also an even function with different. This is a scale wave. Previous one is the different. That's the also it also swings on the negative side. The previous example, but it swings on the only the positive side. This is the time period Cn. Since nothing is existing from, if you are going to start from this time period to this time period, nothing is over here, so we can just take it from minus t by 4 to t by 4, and the rest of you can just simply ignore, and you have a value of Cn over here. Okay, then Cn can be computed by the value of the m, and things are pretty simple and pretty easier over here. You need to you don't need to worry too much about that. And hence the for the even function, uh, c naught is 0, but however this is not an even function, this is the odd function. So that for that function we need to evaluate c naught. We already know this c naught is the average value. You know the principle how we can compute it, and it shows up to 1 over 2. This is just the uh, simplest form of this one. For even case, if you sorry, go back. If you write down in the sinusoid form, for even it is 0 because it's involved pi by 2. If you even 2, then it is pi and it is 0 like that. Yes. How to plot this? This is the magnitude, this is the phasor, this is your Cn. 0 for the even, and for the odd, if it is 1, then it is simply 1. If it is 3, it has some power, it is minus 1. Look at the magnitude, since it's this one, and you can just estimate the strength using that. uh, and for the case of the angle, it's a phasor spectrum or amplitude spectrum can be estimated from this Cn. If you have a computer program running, you can easily estimate these phasor. Even you can manually write down this kind of complex scenarios. It is not a big deal. Okay, this is a Fourier spectrum, the graphical display of the amplitude and the phase of complex Fourier coefficients at the fundamental and harmonic frequencies. The periodic sequence pulses. The Fourier coefficient, you already know that it's written like that, and for this particular case, it can be evaluated in this way. Not a big deal. It's similar to the previous case, and you can just simplify it like that. And it's our function. You can get the value of the average value of this pulse. This is a repetition. Just the repetition, and you can get the Fourier spectrum like that. You already know that this is for the rectangle, rect or rectangle or this kind of shape, it's a sinc function. Fourier spectrum is a sinc function with a take running around it. Okay, let's keep moving. You can simply plot these from here. It's just, you know, that's the same function, and your it's the same function at different values, which could be this is your this is the argument of that same function 2 pi by beta depending on the value of n. Okay, truncated Fourier series. Practical calculation of requires that we need to truncate the series to the finite number of terms, and then we have a mean square errors, and we should consider important coefficients only. That's why it could be written like that, that your function is approximately equal to that one and there is some error if you truncate the sum. Surely there is large number of like that. If you select a certain period or certain window, then you need to subtract some error. Suppose if you want to construct that function of the period function and you select 15 terms, there is then the actual constructed value from that series is kind of overshoot. You will see. If you keep on increasing this number, then this overshoot will be smaller. Actually, this is since these functions are the sum of sinusoids, so large number of n as long as large n is stable function. Now let's come back to our points, circuit and the Fourier series, which is very important in terms of the. It is often defined to determine the response of a circuit excited by the. We are always called a response of a circuit to the pulse, to the impulse, to the step function, to a rectangle, to this kind of periodic signal that we call a response of the circuit. An RC circuit we need to find the output. Pretty interesting. Cross the capacitor, and it is excited by this kind of function. We are given with these values, and time period is pi second. That's actually what we have to do. We need to break down. We need to get the Fourier series of our voltage source, then apply a superposition principle, add these voltages in a, you know, voltage division rule. Consider the number of sources from the Fourier series term and take the voltage division rule across these two and add them up. That's the principle. You know that sometimes you see the waveform. If you just apply on a certain software this kind of signal and see the waveform on a say signal generator, sometimes you have a hard time to understand how this waveform would be like that. This is the answer for that. You just break your source into a Fourier components like V0, V1, V2, V3. Take the voltage division rule, add all the voltages across this capacitor, then you will see okay that waveform is similar to that one which you and otherwise during the time using a time domain you never estimate that or you can never predict that thing. Each input is a sinusoid using phasor to find the steady state response to the sinusoid. Okay, like that. Each is a sinusoid. You already know that. Apply those two You know that this is a frequency component. This is 2 omega. Okay, 135. Since you know that this is a even function, for that you know that the even coefficient won't exist. 2, 4, they are absent. This is based on your previous knowledge. He just skips that over here. This is, you know that 1 over 2 pi fc, that comes from there. Okay, this is the complex form. Okay, yes. Okay, you just simply write on that like that. Oh, no, it's your job or it's your duty. You know that the average value for the even function of this kind is 1 over 2, and you already estimated the ease. You already estimated these from the previous. If you go back and check the even function, yeah, here you already calculated these. This one, or if you go for the trigonometric form, you already estimated. Okay, here, where is the trigonometric form? Yeah, you already done that. You just simply write down that thing over here. Oh, sorry, too much. Yeah, you simply just write down that here and pause it. It just exists for the odd numbers, and we go for the omega naught is 2 radian. It is computed from the time period, and it is 1 over 2, 2 over pi cos omega t. Your voltage source has been broken down like this. Steady state response can be found from this one. Take the voltage division principle, add them up. Okay, this is your source broken. Maybe the impedance of the capacitor is given by, okay, and you can find using the voltage division principle, and this is just simplify. This is true. This one, this has some value. This has some value, and depends on. And this is the voltage division rule between the capacitor and the resistor, and actually your output will be like that. There is a function and it has some angle, and this is the shape of 1 over 2, 2 over 2, and your angle is 0, and look at this one. Just add it up, V0, V2, V3. Just put from here using this formula. Okay, actually we are discussing over here. We already found the values of this voltage and the phasor. Actually, maybe you are confused about how you can get the phasor, but at this moment, I think you should be mature enough to go and take the literature for that. In your circuit analysis, you have done some work with the phasor, how to estimate the phasor from the for these values. Look at that. This is the average value, and this one is the your total function. Okay, this just add them up and just put those values over here. This is cos n through t. Actually, it comes from here to put the values of these 2t, 60, and 3t1, 3, 5, and these angles comes from the that's the summary of this talk. We have seen the importance of the Fourier series in circuit analysis, and it is very important. Thank you very much.